Raneem, am I audible?
Yes, ma'am, you're audible.
Okay. Raneem, we didn't practice any questions on potential energy. Right, so there is one good question that will cover the concept of potential energy, which I wanted to discuss. Remember, I told you the formula of potential energy is K Q1 Q2 by R, but we didn't discuss any questions based on it. So, if you remember, I told you that potential energy is completely dependent on the forces. Means if two charges are present and they are able to exert force on each other, then we say in our system there will be a potential energy existing. Means if you see two charges are there, they are able to exert force on one another. We'll say that one potential energy will be present in the system. So Raneem, look at this figure. What do you think out of all the four, A, B, C, D, four charges are there? Just tell me, according to you, what do you think is the number of potential energies that are possible? Like how many potential energies are possible?
Ma'am, since all are in opposite signs, will it be zero?
No, 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 no. Why? Potential energy means force will be able to exert or not. Will it be zero or not? That means the net potential energy can be zero or it cannot be zero. That we'll see after calculation. That's a different thing. That is the net potential energy. I'm saying how many number of potential energies do you think can exist? Two charges, if they are able to exert force on one another, will make one potential energy.
Yes, ma'am.
So, so what do you think is the number of potential energies?
Ma'am, if we consider like each charge, is it 12?
What?
Like, ma'am, like for plus
See,
Q,
two
minus
charges
Q.
are there. Two charges are there. They'll make
Yes.
one potential energy. Now tell me.
Ma'am, 4.
Four? Check again. Do you think it's four lesser than four, more, greater than four, or four? Then finally tell me your answer.
Ma'am, sign doesn't matter here.
Sign will matter in the solving part. Right now we are just seeing the number. Even if it is negative, a potential energy will be existing. Okay, finally when you calculate the net value, then it can be zero or something.
Then 2, ma'am.
Two. How?
Ma'am, if you consider minus Q plus Q, minus 2Q plus 2Q.
Minus q minus 2q. You say this is 1 plus 2q minus q. You say this is 2. That's it.
Oh, 4.
4?
No, ma'am. Just a minute. 6,
Then
6,
that's
actually
an answer.
6.
Perfect. Very good, Rani. If you are able to identify this, now you'll be able to solve any question. That's the correct answer. 6. Which ones you were not including earlier?
Ma'am, I was not including diagonals.
Diagnosis. Exactly. So this actually happens. Now Ranim, you'll be able to answer any question if you are able to identify this. See, now let me give you a concept. If you are able to identify understand this much, you'll be able to understand the whole concept of potential. Basically, two charges are there. You know, Coulomb's law will be exerted between any two charges. And what is the condition for Coulomb's law? There isn't condition regarding the sign of the charge, right? That's not what we have studied. That a sign is mandatory, negative is mandatory, positive is mandatory. No, this is not what we have studied. For Coulomb's law to exist, you just require two charges and they should be separated. Correct?
Yes.
This is it. So between Q and 2Q, I am able to see that yes, they will be able to exert force. Means you can see the interaction. Do you think are these two charges interacting? Yes, they are. They are separated by distance. So here you will get a potential energy. Likewise, these two you get a potential. These potential energy. These two potential energy. Also, many students forget this. They, till here only they write their answers. That will make it incorrect. Because these the diagonals are also interacting with each other. These are also separated by a distance and they can also exert force. They are also interacting. So this becomes the fifth one and this becomes the sixth. Now, if you're able to identify this much, that is the very first step because the rest of it is the calculation error. Now, whatever wrong you will do will be in your calculation error. But getting the number of energies correct, that's the first. Okay, for every energy, just write k q1 q2 by r. Means q1 means that charge, q2 means the second charge, r means the second. If it's negative, you will put minus because it's a scalar quantity, right? This potential energy is a scalar. So we cannot take the magnitude. We have to write the directions. We have to write the signs also. See what will be the net potential energy if I write. For these two, Tk q into 2q divided by a. Right? First. Can you tell me for the second one, Rani?
Ma'am, K minus Q
Hmm.
to 2Q by A.
Yes, perfect. Minus k q to q by a. That minus sign I've written it here. Correct. Similarly, when we come to 3, both are negative this time. Right? So it will be plus eventually minus into minus q into
Yes.
minus 2q is plus only. So I'll write it as plus k 2q into q by a. Okay. Actually, they both are negative, but when you multiply, it will be positive. One is positive, one is negative. So this will be negative. Minus k q to q divided by. So 1, 2, 3, 4 I have written. Now comes the diagonal. See, we need the separation of the diagonal because this time A cannot be used at least, right? We want this. So this is a right angle triangle and I've already told you. What is the value? Do you remember?
A
Separation.
by root 2.
A by root 2 is for half. A root 2
Oh,
is for the
A
complete
root 2.
diagonal. Okay. Because see, it's like under root A square plus A square. That is under root 2A square. Okay. So that's why this is A. If it was half of it, like in the questions where we have to take the center of the square, then it will be a by root 2. So see, now when we are talking about the diagonals, can you just tell me one? Tell me this one. A, C.
Ma'am, K plus Q minus Q by A by root. I
A
mean
root
A root 2.
minus K Q into Q because both are Q divided by A. And the last one, sixth one is left. This will also be negative because 1 is negative. Minus K into 2Q into 2q divided by a, like this. Basically, I am taking individual energies and I'm adding them. That's what I'm doing.
Yes,
Now
ma'am.
look, let me write it a little properly. Now comes the solving part. Your entire concept of potential energy and everything, whatever was there from your class 12, that is all. Now what do you require? You just require the concepts of mathematics. That's it. You should just know how to simplify an equation. That's it. So if I write it, if I simplify, if I write it, this will be uh, 2kq square by a. This will be minus 2kq square by a. This will be plus 2kq square by a. This will be minus 2kq square by a. This will be minus kq square by a root 2. This will be minus
4.
4kq square by a. ये चार तो कैंसिल हो जाएंगे है ना 2kq square by minus 2kq square by a,
Yes.
and this will also be cancelled. So only this will be left. So see, if you take only the 4 by mistake, your answer will be 0, which is not in this. I think let's take minus kq square by a root 2 common.
Yes.
So we will be left with 1 and from here 4.
4.
1 plus. So finally our answer is minus 5kq square by a root 2. This is the potential of this. Understood, Rani?
Yes, ma'am.
Please write down this question.
Yes, ma'am. Ma'am, also, our vacations are gonna start from June 6th onwards.
June 6th. Okay.
Yes, ma'am. So, ma'am, during that time, can you just teach me how to use the logarithm sheet because that'd be helpful in calculation?
You are asked to use the logarithm sheet.
Yes, ma'am. We've been
Physics or
provided with it.
chemistry?
Ma'am, either physics or chemistry. Physics mostly we require for practicals.
Okay, okay, I'll teach you that in your one of the classes of English. I'll teach you log table. So you should have the log table with
Yes,
you.
ma'am, I'm having.
Okay, okay.
Ma'am, done, ma'am. Ma'am, done.
Raneem, just one more thing. We didn't discuss parallel plate. The derivations did we discuss?
Ma'am, you asked me to note them down.
You have written the derivations of parallel
Yes.
plate.
Yes, ma'am.
Did you understand it?
Ma'am, it would be better if you explained again.
I'll explain you again. See, Raneem, in parallel plate capacitor, because whatever things were left, no, that's all those things only I'm completing. Then with fresh current electricity, we'll start. Because when you already have, you have written the capacitor things, no? What is a capacitor and all? That you know what is meant by a capacitor. That also we discussed, I think.
Yes, ma'am.
Parallel plate capacitor, see, when you have two conductors, you decide the shape of the conductors, and depending upon the shape of the conductors, they are categorized into different types. One is a parallel plate capacitor, second is cylindrical capacitor, third is a spherical capacitor. So cylindrical capacitor I'll discuss you in the next class, because I'll just give you some of the formula of capacitor. Not even the next class, after is that's not very important, but it's there in your need. Means it can come in your need. There are a little bit chances of it.
Okay, ma'am.
Most of it have the questions from the parallel plate capacitor. So that's what I wanted to discuss. I just wanted to practice some questions, because without questions practicing, things that never get cleared. Through questions only doubts and all come. See, there are only few steps that have to be followed whenever you have parallel plate capacitor. One is that calculate the net electric field. That is the first. I'll tell you for the first one. Rest of it you'll be able to do. These are the two parallel plates. Okay. You, I think, took the screenshot of these, no?
Yes, ma'am. I took screenshot, then I
Have you
wrote.
written?
Yes, ma'am, I wrote.
Great. See, when we add the net electric field, like sigma by 2 epsilon naught for this one, sigma by 2 epsilon naught for this one, that becomes sigma by epsilon naught. Then what do we do? Basically, we have to write the potential. What is potential? Potential is electric field into distance according to the formula of potential gradient. Electric field is sigma by epsilon naught, and sigma is q by a, charge per unit area. So q by a epsilon naught into d. This becomes the potential. So this is the step that you have to follow. Calculate the net electric field, put the net electric field in the potential. Once you have the potential, put it in the capacitance. When you put it in the capacitance is charge by voltage. So charge divided by voltage. Voltage is QD by A epsilon naught. So QQ will get cut. You will just have epsilon naught A by D. Okay?
Yes, ma'am. But why are we taking Q by epsilon naught?
Here,
Yes.
because sigma's formula is this charge by A.
So, ma'am, depending on the shape, we can take it.
Shape is fixed. Parallel plate capacitor we are taking. So shape is a plane sheet, a plate. That is fixed.
Also,
That's why.
depending on surface charge density.
Yeah, surface charge density we are taking, because we know it's a plate. Plate
Yes.
is a two-dimensional figure. So since we are deriving for plate only, that's why we have taken it as q by a. If the figure would have, like, if it's a spherical capacitor, you cannot use this, because spherical capacitor is different. Right. So this, since we know this is a plate, that's why we are using this. Similarly, Raneem, for a dielectric medium, we always multiply it with K. So it will be K epsilon naught A by D.
Yes.
This part is important where it is partially filled. Okay, partially filled dielectric slab is partially filled. So see, Raneem, Here, separation between the plates is D. Thickness is T. So when we write down the potential, what is the potential? Potential of the dielectric slab will be electric field of the dielectric slab into its length. Similarly, electric field due to air will be potential due to air will be electric field due to air into its distance. That's what we write potential's formula, E into D. So for air is not completely present. Air has some of the parts in between, right? Where this part is there. Because some portion has been enclosed by dielectric, we cannot completely take it as D. So till
Yes.
where, in which portion is the dielectric slab present? It is present in T. So till where do you have your air? It is D minus. So that's why we write electric field due to air into D minus T. And electric field due to dielectric is electric field into dielectric into T. Now, what are the values of this air and dielectric? See, air is similar to the first part, sigma by epsilon naught, right? For the first
Yes.
one, sigma by 2, sigma by 2. So ultimately, it will be sigma by epsilon, right? For these two. But electric field due to dielectric, you cannot put it as sigma by epsilon naught because dielectric constant will come this time. So we'll multiply it with K. This is the only difference that will come. This is sigma by epsilon naught. For this dielectric slab, it will be sigma by K epsilon naught. So potential is Q by A epsilon naught when you take it out. Sigma, you will put it as Q by A. What will be left? From here, D minus T. From here, T by K. That's all. Put it as C is equal to QV. You get the formula. Okay. Anything you want to ask from this? It's clear?
Ma'am, we have to consider for both D minus T and the D by T.
D minus T and T by K. This one.
Yes, ma'am. We have
Yeah.
to consider for
Yes, yes.
both.
Because see, electric field will be there due to the dielectric slab. We know that. And electric field is already there due to air. Correct? So these two things are
Ma'am,
already present.
we took E naught.
E naught is usually represented for air. Remember epsilon naught when you write it
Yes.
for air. So that's why I've written E naught means air, electric field due to. And this I wrote D, electric field due to dielectric. Okay?
Yes, ma'am.
And see, in this one, this is here, it says that instead of the dielectric slab, a conductor has been, okay, instead of the dielectric slab, a conductor has been put. The best part is that same thing, you will write electric field due to air into D minus T plus electric field due to conductor into T, similar to the previous one. But electric field inside a conductor is zero. Remember we discussed in the Gauss
Yes.
theorem class part. So
Yes, ma'am.
this part becomes zero. That's why here in this you only are left with D minus. Okay.
Yes, ma'am.
Arani, one more thing I want to discuss. You have these things written now till here.
Ma'am, mm, the conductor one, I don't think I wrote that one.
Just check it. You don't have them, please write because all the four parts are there. And in your revised syllabus also it's there.
Conductor, I didn't write. Rest important ones we discussed.
So just write down this one.
Ma'am, till when is today's class?
It is still 7:30 means 1 hour class only we have. Uh, it was supposed to be 1.5 hours, but
Yes.
it started half an hour late. No, it will be completed on its actual time only because the problem is that there are batches after your class. 2 to 3 batches are there. So that cannot be disturbed. Okay, so
Yes,
that's
ma'am. After 6 June, like I'm having holidays, so I'm available the whole day.
you're available. Okay, I'll just tell this. 6 June, you said, no? Okay,
Yes.
let me just inform the team also. Okay, they'll have this because they schedule all these classes and all. I'll just tell them.
Ma'am, ma'am, can we write derivations in a more systematic way, like consider statement and then all the statements that are referred to below? Because like,
Mhm.
ma'am is cutting marks for those also in our
Yes, the
school.
marks are cut. The marks are cut if you don't mention anything. So, okay, you're not in a habit of writing it. You
Not
just
really.
okay, okay. Then I'll put the same statements. Okay, because those are in your CPSC board exam also marks will be cut. The in the derivations they have a segment. Okay. Let me write it here then. Can I?
Okay, ma'am. Write down. I'll note down. Ma'am, for the consider part, should I write consider a parallel plate capacitor with conducting slab partially filled?
No, that's the actual heading that will be given in the question. So you can just that will be present in the question. So yeah, you can write that statement. That is also not incorrect. But even if you leave that, that's okay because
Okay.
it will be mentioned in the question.
Ma'am, you can scroll. Ma'am, it's not necessary to put equation 1, equation 2, equating 1 and 2 and all that, right?
See, Rani, in this particular it's actually very important when you write. But in this particular derivation, we don't actually have many equations. We are just putting we have electric field, we are putting it only. Potential, we are putting it. But otherwise, in equations, you need to. Okay, 1 or 2. If you are not in a habit, then I'll just write it in the, because I just have a habit of telling it in the class, and I write down the main points of the derivation. So that's why these things are not written. This is actually from a class only that was done. Because of your exam, I couldn't discuss it with you now, but from the current electricity chapter, whatever derivations we have, I'll write it down and everything. I understand how you want now. Because see, in your school exam, what? Leave your school exam. In your board exams also, marks are there for it. You cannot just write, like if I just give you a derivation and I write and I just write down C is epsilon not D minus T. What is D? What is T? Why? How is it epsilon not A by B minus T? So these things are important. Okay.
Yes, ma'am.
Just let me know once done. Done?
Ma'am, done.
Just one numerical practicing learning. Okay. That will give you an idea about this. A neat question only, but it's a very good question. See, this says a parallel plate capacitor having cross sectional area A and separation D. So area is given as A, separation is D, has air in between the plates. Means initially, this is not the case. Initially, what's the case? A capacitor is there with air filled. This is the original case
So, ma'am, without medium.
without any medium. It is saying a separation has air in between the plates till here. This is the initial case. Then it says now, means now a modification will be there. What is the modification? Insulating slab of same area. Okay, let's say cross sectional area is A given and this separation is G given, है ना? But thickness B by 2 means T value of T that we write, thickness is B by 2. And same area is there, area is A, between the plates is put like this. Okay, so it is partially filled, right, with the distance D by 2. It's not necessary, no,
Ma'am,
that
it's
will
the
always put it in
same
the middle.
area as the original one.
What? What, Raneem?
Ma'am, is it the same area as the original one?
Yes, yes, it's the same area. Look, it has written on the same area. Same area as that the original one. So if this is a, this will also be a T is equal to D by 2 and distance is also given as distance, right? Thickness is given as D by 2. So this is the partially filled case. See, it's not necessary that you always will have the diagram like this also. If the same slab is shifted towards the edge, that is also partially filled like this.
Yes.
So this is that case. So which formula, Rani, for capacitance?
Ma'am, the one that we just learned, partially filled.
Tell me the formula. Look in your register.
Epsilon A D into T by K
D
minus
minus T plus T by
oh
K. है ना?
yes.
Yeah, right, correct. So it has given you the value of K also. Inserted between the plates as shown in figure having dielectric constant K, which is 4. See, a parallel plate capacitor having cross-sectional area A and separation D has air in between the plates. So this is the case.
Yes.
Tell me, let me write this as C only. Tell me what will be the capacitance for this one.
Ma'am, A by epsilon naught D by
A
T.
by epsilon naught.
No, ma'am. A into epsilon naught by D.
Epsilon naught A by D. Perfect. Now this is the second case which has been inserted. This is the second case. This is the first case. It is saying now an insulating slab of same area. The area is same. Area is same means area of the plate. We always take the area of the a plate is like this, right? A plate is like this. But since we just draw a straight line. Then it is saying now an insulating slab of same area but thickness d by 2. T is given as d by 2 this time. Is inserted between the plates as shown in figure, and dielectric constant whose value is 4 is also given. It is saying the ratio of the new capacitance. Let's say its capacitance is C dash. Okay. Let's say C dash is the capacitance of the new slab inserted. Whereas, let's say C is the original capacitance. So what do we need to calculate? We need to basically calculate the ratio of C and new to original. Means you have to find out what is C dash by C, right?
Yes.
So let's find out the capacitance of the new one. Formula you said it right, epsilon naught A by D minus P plus T by Q. So when we put in the values epsilon naught A, D is D, thickness is given as D by 2 plus thickness is D by 2, and what is K? K is given as 4. Have I written it correctly?
Yes, ma'am.
So this will be epsilon naught A by D minus 2 plus D by 8. Let's take D out and common. Epsilon naught A by D, if I take it directly out, I'll be left with 1 minus 1 by 2 plus 1 by 8. At least if we'll be able to solve this better. Epsilon naught A by D, LCM is 8. 8 minus 4 plus 1. So 8 minus 4 is 4. 4 plus 1 is 5.
5.
So this 8 will go up. It will be 8 epsilon naught A by 5D,
Yes.
right? So
Yes.
see, original capacitance is given as, now let's see the ratio, C dash by C. This is 8 epsilon naught 8 by 5D, whereas C, sorry, I've written both of them. Whereas C is just epsilon naught A by D. D gets cancelled, epsilon naught A. Ratio should be 8 is to 5. Let's check the options. B1, है ना?
Yes. B.
Okay. Okay, write down this one. This is from your NEET 2020 paper, the COVID time.
Yes. Ma'am, we can scroll. Ma'am, ma'am, what is the NEET syllabus for this year?
Neat syllabus.
Ma'am, because they say that from 11th it's 25, like from 12th
Okay, okay,
is
okay. I got it.
85%.
I'll share that with you, Raneem. The weight
Oh,
distribution of marks and
oh
everything.
yes, yes,
Because
ma'am.
some topics are extra also, but they are very less. 20% topics are extra from combined your 11 10. Okay, I'll share that in the next class. I'll discuss.
Okay,
I'll tell you the whole details about it. Okay.
okay. Ma'am, you can scroll.